Okay, hello Physical Science, this is Mr. B, and we are going to wrap up Chapter 12 today with our last universal force, and it's one that is kind of one of the most effective ones over long distances, and that universal force is known as gravity or gravitation, as Newton calls it, because he has Newton's law of universal gravitation. So this is our last force that occurs, again, everywhere throughout the universe. So Newton's law of universal gravitation, again, gravity across the universe, states that every object in the universe attracts every other object. So every object that's ever existed has an attractive force between the two. So no matter where you are, no matter who you are, no matter who you are or where you are, how big you are, how small you are, there is a gravitational force acting between every object. So gravitational force is an attractive force, so it wants to bring objects together that can act between any two masses, and gravitational force depends upon mass and distance. So if we look down here at this example, we have object X and object Y, and they're the same mass and they are exerting a gravitational force upon one another. And then if you look here with object X is much bigger, has a greater mass than this one, you now look, we have a longer blue arrow. And remember, the arrow is indicative to magnitude, meaning that because it's longer means that there's a greater force. So because gravitational force, because the mass is bigger here, there's a stronger attractive force over the same distance. So if you have a bigger mass, that means the more gravitational pull you're going to have. And if you look here now, we have the two smaller masses much farther away, and then they have a very weak gravitational force between the two of them. So mass and distance are going to be what determines how strong the gravitational force is. And so the gravitational force between two objects is proportional to their masses, which is what I just said. So, meaning the larger the mass, the greater the gravitational pull. The lower the mass, the less the gravitational pull. And gravitational force decreases with the square of the distance between the objects. So that just means the farther the distance between the two objects gets, the more that gravity is going to decrease. So it's gravity works better when you're big and when you're close together. If you're small and far apart, you're most likely not going to feel gravity, because gravity is in fact the weakest universal force, but it is the most effective force over long distances. So remember, we talked about strong nuclear force is a very strong force. It can overcome the electric force of repulsion that occurs between two positively charged protons. However, gravity is going to be much weaker than that. However, it can occur over a much, much larger distance. And we don't necessarily even feel gravity working, but it is present in our lives all the time. And a big example of gravity involves the Earth, the Moon, and then tides. So maybe you've heard this before. So the Moon's inertia, again, the tendency to resist a change in motion, acts to move it away from Earth. So the Moon and its kind of tendency, its natural movement based off its inertia, it wants to move away from the Earth. However, Earth is so large that it has a gravitational attraction, and it keeps the Moon in a nearly circular orbit around Earth. So the Moon has the inertia to say, hey, I'm going to kind of move away, or I'm going to resist a change in my motion, or I just want to kind of stay in one spot. I don't really want to move. However, Earth's gravitational pull combined with that inertia results in what's called a centripetal force. So this is important, and it is a center-directed force that continuously changes the direction of an object to make it move in a circle. So that's what we have here. So the Moon's inertia combined with the gravitational pull of Earth result in a nearly circular orbit. So the Moon will move around the Earth in a almost completely circular orbit with a combination of inertia and gravity, and that's called a centripetal force because it moves in a circle. And then as a result of this, a big occurrence occurs in our oceans. The gravitational pull from the Moon produces two bulges in Earth's oceans, one on the side of the Earth closest to the Moon, the other on the side farthest from the Moon. And as Earth rotates once per day beneath these two bulges, there are two high and low tides per day on Earth. So the gravitational pull between the Earth and the Moon actually results in the high and low tides on the beaches in the ocean that occur every single day. So And I think that's pretty cool. I mean, most people have heard of this before, but if not, it's kind of really an interesting example of a universal force at work there. And then another way that humans kind of take advantage of the gravitational force that exists between the Earth, or that the Earth can produce because it's so large, is that an artificial satellite needs only its inertia and the centripetal force provided by gravity to maintain its orbit. So satellites that are in a low orbit are going to be slowed by friction with the Earth's atmosphere, and they'll eventually re-enter Earth's atmosphere. So humans have kind of been able to take advantage of this gravitational force. They can launch satellites up, and they can actually cause satellites to orbit the Earth. And that's important because humans use satellites for a lot of different things. They can use it for monitoring the Earth's weather, creating detailed radar maps of Earth's surface, using telescopes to study space, studying Earth's climates, and then receiving and transmitting radio and microwave signals, and then also your televisions, a lot of you, satellite TV. Again, you can thank Earth's gravitational force for that. And then again, satellites are used to receive and transmit electronic waves over great distances. So here's our example maybe of how satellites can help us with our TV every single day. So that is it for gravitational force, again, our last major universal force, and that is actually it for chapter 12. So let me know if you have any questions.